Okay, so I guess the session is recording. So in previous video, if I will maybe go with this thing, we saw how different optimizers were working. Okay, and maybe I maybe try to show you some of the most used optimizer in the industry, and we compared them like this. Okay, now we have covered ANN and we have covered MLP. Okay, so we have covered multi-level perceptron too. Okay, so now it's time to go with CNN, that is convolutional neural network. Okay, so if really you want to work with images, videos, okay, so for those tasks you will use CNN algorithm. Okay, then there are many variants of CNN algorithm. Maybe we will get into those variants. We will talk about them, and maybe I will try to maybe explain you. But uh, as for the being, what I want to show you is like what is the architecture of CNN. Okay, so before we saw that this was our neural network. Okay, so what we did, we were making input layer, we were making hidden layers, we were adding nodes in the layer. This is how we were increasing the width and depth of our neural network. Okay, then one more hidden layer, then activation function, then output. This was simple neural network. Okay, then we came up. Then now I am saying like I will show you what is the architecture of CNN. Okay, so maybe uh, if I'll come up over here, so CNN, the architecture of CNN will be like this. Okay, as I told you, like CNN will be implemented on images, videos kind of a data set. Okay, so let's say we have given a data set of image, one car as an image. So there will be a convolutional layer, then there will be a pooling layer. Just listen to it, just understand the architecture. When I will be applying the architecture, first I will apply the architecture. I will show you how CNN is different from ANN, why we are using CNN over ANN for the image data and for maybe videos, because then I will explain you everything, no worries. Okay, so there will be a convolutional layer, there will be a pooling layer. Okay, and after all of this, convolutional and pooling, again convolution, again pooling. Don't worry about what is convolution, I will explain you. Okay, then you at the last you have fully connected layer. Fully connected layer is nothing but kind of ANN. Okay, and after that it will predict either this is a car or this is not a car. Okay, so that's the thing. Some of other architecture of CNN are like Google LeNet, LXNet. Then after that we have ZFNet, ResNet, VZZNet. These are some of the maybe updation into the CNN. Okay. So I guess I have shown you the architecture, because this was the architecture of ANN and this is the architecture of CNN. ANN is being used, but at the last. Okay, we can say like this. Before that, we are going with convolutional and pooling layers. So what are these layers? We will dig down into them. But before that, I will show you what is the problem statement, and maybe why we will not apply ANN, why we will apply CNN on the problem statement. Okay. So this is the problem statement. Okay. So inside your dataset, you are having image. This is an image dataset. First, you have to understand it like this. Okay. And there are 10 different images in the dataset. Okay. Images of plane, car, bird, cat, deer, dog, frog, horse, ship, and truck. Okay. These are 10 classes, and these are the class levels. For aeroplane, class level is 0 and so on. Okay, so you can understand this is a we can say image data set. Okay, so our problem is if we will give one input image, our model should predict maybe that's a dog, or maybe that's a horse, or maybe that's a ship, plane, and that our model will predict. Okay, this is our problem, this is our simple problem. You have to make one binary class, not the binary, multi-class classification problem. Okay, this is a multi-class classification problem. So we have to make one solution for multi-class classification problem. Okay, because there are 10 classes, so multiple classes. Okay, so if you have multiple classes and you have image data, then you will not use ANN. Okay, or you will not use multi-layer perceptron. What you will use, you will use CNN, convolutional neural network. Okay, why you will use that? Let I will maybe what I will try to do, I will try to implement ANN and then CNN, and then you will understand only by seeing. You need not to remember anything, because as usual, this is applied course. Okay, so before going into implementation part, you need to again. I'm emphasizing you on this. You need to first explain or understand or maybe answer to yourself what activation function you will use over here. Okay, for output layer. Okay, activation function maybe for output layer. What activation function you will use? You need to answer yourself. As this is a multi-class classification problem, there are 10 classes. So the best thing to use over here will be softmax for the output uh, layer. Okay, and then second question you have to ask yourself, what optimization technique you will use, or maybe what optimizer function you will use. Okay, wait, function. Let me zoom it for you a bit more. Yeah. So I will say I will use add-in, because Here in the last video we saw like how the which optimizer is working maybe perfectly fine. Okay, so here you can see Adam is not working that great, or maybe you can see Adam is working great, but this is not the best option. But again, I'm using Adam. Okay, you can maybe work with all these things. These are hyperparameter. You can maybe choose yours. Okay, then you have loss function. Okay, and what loss function you will use? As this is a multi-class classification problem, I will use sparse categorical. Okay, cross entropy. You have to answer yourself all these things, and then maybe your implementation will be good. Okay, so evaluation matrix. So what evaluation matrix you will use? As this is a classification problem, accuracy. Okay, so these are the prime thing. Before getting, or if you want to solve any deep learning problem, first you have to understand either the data is tabular data, or maybe the data is maybe in the form of images or videos or kind of stuff. Okay, if tabular ANN and MNPs, if images or videos kind of data, then you have to use CNNs. Okay, and the variant of CNN I told you, like maybe LeNet and kind of stuff. Okay, those you have to use. Okay, so I have decided. Then maybe you are having image data, that is multi-class classification data. Okay, then you have to decide output layer, you have to decide optimizer, you have to decide loss function, you have to decide evaluation matrix. Now if you cannot recall them, go back to those videos which we have covered in the past, and you will understand what to use where. Okay, so leverage that thing. Numpy is the NP. So what I'm doing, I'm importing important libraries. Import tensor flow STF. Okay, then from TensorFlow dot keras I will import dataset. So what? So I'm telling you, no, this is multi-class classification problem. So this is a dataset which is maybe freely available, open source dataset, and this dataset is known as Cipher 10. Okay, so uh, let's uh, let's import datasets. Let's import layers. Okay, maybe we will take a shortcut to make that, but again models, and then from keras dot datasets I will import, cipher 10. Okay, okay, so everything went good. Now I will directly import it, so I will train it directly, split it. Okay, if you will, maybe you have to do this process using train test split. Okay, but as this dataset is available to us openly, and this keras dot dataset provide us this dataset, so I'm going through it directly. Okay, no need to apply train test split kind of stuff and anything. Okay, so then y test. Okay, and then dataset dot cipher. I guess this will work. I will load it. Just load this data. This is what I'm telling it. Okay, and now what I will do, I will try to show you the shape of the dataset. Okay, so that's the shape. That's the shape. Again, you can see it is first it will download the dataset. Okay, and directly it will show us the shape. So let me do one thing. This is not that clear. Okay, so that not that I freezing. So you can see X train and Y train are paired because there are 50k data points, and again there are 50k data points. Okay, and then this is the dimension. So by looking this dimension, you can say your image height is 32, your image width is 32, like this, uh, like this. Let me have this 32 by 32, because this is how your image looks like. Okay, okay. Let me speak some more word on images. Okay, so what I'll do, I will say image metrics. Okay, I'll show you directly like what the image look like, so that maybe your intuition will be developed, like images matrix in CNN. So again, I have to cover some computer vision part. I have to cover what is the image, what are pixels. So pixels are the smallest unit out of which image is made. Okay, so and its value is from 0 to 255. That's the range of the pixel. Okay, so that's how the image is made. And when I say flattening, like here CNN is here, no. So when I say fully connected layer, so after that it will flatten the data. Flattening means this was the data in the matrix form, and we are maybe putting it like this. Okay, so that's the flattening. If maybe if in the past I would have used flattening and you would not be able to maybe relate, then that's the flattening. Okay, and then let me come up with some of the more examples. Actually, I was not trying. Maybe I was not. Uh, I was not that convinced to show you, but still, that will increase your intuition. Okay? So this is an image, and you can see every value. So this is the matrix. This is how computer sees images. Okay. So why image processing is very maybe why computer vision and this image processing, these things are very difficult task for computer, because as a human we can understand this is a letter 8. Okay. But uh, as a computer, because computer don't see anything maybe in any language other than 0 and 1, that is binary. Computer work in binary. Okay. So computer understand only digits. So the way computer understand images is within a range of 0 to 255 values only. Okay. So here you can see everywhere this is 0, but wheresoever there is a this 8 letter. Okay. Or letter will be not a good thing to say, where this is a 8 number 8. See, these boundaries are filled with some numbers. Okay. As you can see, so you can always relate with the boundaries. Other values are 0. See, this is the highest value, 255. Sorry, 225. Okay. And this is the lowest value, 0. Okay. So everything will range between 255, 225 and 0. Nothing else. Okay. Nothing more, nothing less. Okay. So this is how a computer interprets an image. Okay. So I guess this is more than enough to understand. Maybe shout out to these people becoming human.ai. Uh, then yeah, I guess this is more than enough to maybe make you understand what is happening. Okay. So this is how CNN will extract. So what it is doing, it is only taking some of the part, and again there is convolution. ReLU is an activation function, as you can see. So I am dropping ReLU for now. So convolution, pooling, then again convolution, then again pooling, and then flattening. See, this is how flattening works. Okay. I
It's on
showed
the
you.
top.
Then you will make fully connected layer, and then softmax activation function. So if I am putting softmax as an activation function, you can understand either this is binary classification or multi-class classification. Okay. So you have to understand all these things, because I have told you every time these things. Okay. So one more thing I want to tell you, like if you will see that image, if you will recall this image. Okay. So this image is more clearer. So I'm not getting into more depth, because maybe this is applied session. Just I want to give you some intuitions. Now there are some horizontal edges and there are some vertical edges. Okay. So this is how. So by understanding what this maybe this is a 8, you can understand it. But how computer will understand? It will go through all these edges. Okay. And it will see these numbers, interpret these numbers, and it will divide this number into horizontal and vertical axes, into width and maybe height. Okay. So to understand horizontal and vertical things, there are different kernels to put on. Okay. These are vertical kernel, these are horizontal kernel. If you will multiply it by this, these are the horizontal component. If you multiply by this, there will be horizontal component. If you multiply by this number, there will be vertical component. Okay. So these are the horizontal component right now you are understanding. Okay. That's how it learns. Maybe this is not, maybe this is not a best explanation. Don't worry. We are just this is the starting, so don't worry. So I showed you 32 into 32. This is the image size, width and height of the image, and then 3, that's the channel. Okay. So there are different kind of images. There is black and white image. There are different kind of images. Okay. So this is the first. So 3 channel R, G, B, red, green and blue, and every channel will have a value between 0 to 255 to 225. Okay. This is the range. So based on this number between 0 to 255, so this is a kind of bucket which can hold at most 225 number. Okay. So based on this number, the maybe how dark this red will be, how light this red will be, that will be decided. Okay. So that's the thing. So there will be 3 channel. R channel, G channel will be behind this like this. Okay. And B channel, again I need to show you RGB channels. Okay. That will be useful for you. So there can be RGB channels. There can be no one channel only for the black and white image. Okay. So for the colored image, there will be RGB channel. Okay. So this image will maybe tell you perfectly. So this was an image of a dog. Okay. This was an image of a dog. This is a RGB image. So there will be some component, some red component, some green and some blue component. Okay. So that's how and that's why this thing this thing are having 3 dimensions. So if you will see something like this, you can understand this is a RGB image. Okay. So that's the thing. Okay. Now these are the dimensions. This is for training. This data set is for testing, and maybe if you will try to understand the segregation, or maybe the part which is given to the maybe what we can say, to the training, and the part which is given to the testing. Okay. So by part I mean maybe what we can say. So we can say like maybe 70% of the part is for training, and maybe rest of the part is for testing. Okay. So if you will understand this dimension. Okay. So its dimension will be 4D. uh, okay. And this thing, the training is having 2D dimension. Okay. So if you really want to see, or I have to maybe show you, that will be more useful. Okay. So if we'll save, and if I'll take len of it, it will be a maybe 2D. Okay, so what I have to do, maybe, and then I have to show you this thing, train.shape. That will be again useful, maybe, to have a look on. Okay, now you can see 2 and 4. Okay, so what you have to do, first I will apply ANN on it. Okay, a multi-level perceptron MLP. Then what I have to do, I have to maybe reshape it. Okay, I have to reshape it. So white train dot reshape. Okay, then I will show you how this receiving is not required, how why this receiving is required. This thing we will maybe we will have a discussion on it. Don't worry, just see what different thing to do in maybe RNN and CNN. Okay, not RNN, ANN. Okay, so these two things you can see. And now I have received them. Okay, numpy object is an attribute to receive. So that's not the proper spell for receive. We save. Okay, so this will work fine. Just I will copy y test from above. I'm copying y train from above. I know you are understanding nothing for now. Don't worry. Just see the architecture. Right now, I'm discussing only on the architecture, and I have discussed 2 points, which again I will maybe let me write it safe and let me run it, and I will go over here. You need to, this time we are only emphasizing on these 4 points. What evaluation matrix to use, what loss function to use, what optimizer to use, what activation function to use. If you know these 4 parts, and if you know nothing about CNN, and you know the architecture of CNN, and you know how to apply this architecture, you are good to go. If you don't know what convolution is doing, maybe again you can implement it. Okay, then if you will have to run maybe if you have to show the efficiency, then maybe you need to understand what is convolution and everything. But for this time being, I'm seriously concerned about these factors. Like, I want to show you how, maybe how to implement these things. Okay, so this is how we have maybe transformed them. And now I will come to y train, and I will try to find out the first 4 point. Let me show you the first 4 point. Okay. So this is how the first 4 point looks like in y train, and in y test. Let me come up with the first 4 points. This is how the first point in y train looks like. Now you might be thinking, what is happening? No worries. I will see for you. I will maybe try to run this code again. Okay, no worries. Then I'll show you what we have done here. Okay, so let me come up with this. Let me show you X train. Okay, so X train. This is how X train looks like. See, 1, 2, 3, 4. 4D data. Okay, so maybe 3D, 4D. This is how every image looks like over here. Okay, and maybe I will go with uh, again some net issues maybe, but uh, I will go with index 4. So this is how all things looks like. Okay, up to index 4. First image, second image, third image, fourth image. Okay, if I really want to see the first image, that's the first image. Okay, that's the matrix of first image, which I was maybe showing over here, that how the matrix, how the image is divided into matrix for the being that computer will understand it. Okay, and we have done so in training and test, we have converted them. Okay, then y train and y test we have converted them, and y train was having all these things. Okay, so if I'll maybe come up not from here, yeah, from here. So you will see it was a 2D thing. Okay, and now what we did, we received them, and now they became the 1D thing. Okay, they are now in one dimension. Okay, so now I have to decide the classes. Okay, so airplane, then other classes, automobile maybe, then we have birds. Okay, and then we have, maybe we have cats, and then we have deers, and then we have dog, and then we have frog. These are all those classes. Okay, name of the classes, you can see it like this. Horse and ship. Let me zoom out a bit, and after that you have trucks. Okay, so these are the classes. I will run it directly. And why I'm putting these classes over here, now see. Okay, so this is the X train. This is the first image. this is how computer looks at. Okay? This is how computer see this first image. Okay, this is a whole bunch of matrices. Okay, nested, listed, we can say. Okay, list inside list. Okay, so now you might be thinking what this image is. This is not interpretable for you because this is how computer reads image. Okay, and every value will be in a range of 0 to 225. Okay, so let me show you what this image looks like. plt dot show. Okay, let me. I am showing work over here and train and 0. Okay, that's the image. plt is not defined. Okay, then import matplotlib dot pyplot as plt. Okay, now this will work fine. This is how that image looks like. Let me clear it more. plt dot show. Okay, and then plt dot title, and I will say now I have to give it title. No, so classes, and for classes, y train zeroth class. We are taking something. I will show you what is this happening. Okay, what it is saying. Uh, what is this happening? Only integer is scalar array can be converted to a scalar index. Okay, so some caveats over here. Let me come up again with the code. No problem. Let me remove it. Don't bother about the save. Let's rerun. There are some caveats. If you will rerun it, that will be solved maybe. Otherwise, I will solve it. No worries. So this is a frog. Okay. So that's why I gave the class name. Okay. Now you might be thinking, what is this? What is this white range zero? Okay. Like this is nothing but indexing. If you have covered your list section very properly in Python videos, then this is maybe very easy thing to do. So this is the sixth class. Okay. This is the sixth class in the dataset. So the sixth is the frog. That's how it is relating. Okay. Now if I'll say maybe classes. Okay, and I'll say sixth, which is the sixth class. So this is how it is giving me frog. Okay, zeroth index, first, second, third, fourth, fifth, sixth. This is the frog. Okay, that's how we came to know that this is a frog. So I guess this is maybe very easy, and maybe you can interpret it by yourself. Okay, so now maybe I will try to write one function for it. Okay, because again, if we have to maybe look for different image, then again we have to write this whole code. Okay, so what I want to do, I want to write one function for this code, and after that maybe we will only give the class level. Okay, and that will be, or maybe we can say index, and that will be more than enough to go with. So I will say not index, I will say plot sample. Okay, for every image I am taking as sample, and it will image will be defined by that index, and then plt dot inso the same code. Okay, this is the same code, or maybe let me do one thing. I will take this whole thing over here. Okay, just to so that you will be able to connect the dot. Okay, so that it will not look like as a magic. So what I have done, I have simply copied our code. Okay, nothing else, just make one function for it so that we can call this function directly. Okay, so here in this section, what we can do, uh, we can remove this training uh, thing. Okay, because we are giving variable image x and y. Okay, so we will define here x train, or that is x test, whatsoever that will be. We will be able to say it. Then this is nothing but index. Okay, so I'm changing with this index. We will take index right from here inside the function. Okay, so no worries. So index. Okay, now maybe I will run this, and we will use this function. Okay? So when I said like when I told you like this image is of size 32 by 32 and this is a RGB image, by that I was about to say like, okay, let me first show you. Okay, so here now what you can say, now simply you can copy this thing x train 0, or you need not to put 0 over here. Okay, because we are putting index at the last. So what you will put, x train, removing the index, y train, and index equals to 0, or maybe 0. Okay, so if we will run it, so same frog image is here. Okay, so this is how you will get it. Now maybe I don't know, maybe that this is more than enough to understand. Okay, this is how you have, now we have made this function. We directly have to give change the index. Maybe what is a sixth index, because indexing is starting from 0 now. So this will be 6. So this is an automobile. Okay, I will say for 8th. So it is saying this is a ship. Okay. So images are very maybe depreciated. These images are not that of good quality. But again, uh, uh, machine will find it because machine is only focusing on metrics. Okay, on those edges, vertical or horizontal edges, which I showed you maybe in the previous or maybe sometime back in this in this session only. So let me see how long it have been. Okay, so these all are the pixels. See, these are the pixels. And every pixel will have some value between 0 to 255. So image is nothing but collection of pixels. Okay, and just what computer does, computer understand by putting kernels into picture what are the edges and what are the boundaries. Based on that, what are the value assigned to those edges and boundaries. That's how it understands. So what kind of maybe is it a dog or cat or something like that. Okay, so maybe I will this will be more than enough for this session. In the upcoming session we will try to maybe mm, uh, furthermore work on this code, and first I will apply ANN, and then I will show you why not to use ANN in image data. And if you will remember, in the previous MNIST data we used ANN. Okay, so that was not a good approach to go with. We Because that was again image data. Okay, so I will show you how the dimensionality will increase if you will use MLPs and ANNs on image data. Okay, and how CNN will decrease those dimensionality, and then how maybe it will extract some of the very important features. Okay, so yeah, this is all for this session. Maybe I will try to close this session over here. We'll continue in the next session.